Hey guys, and welcome back to a new video. In this video, or rather in this new playlist, which will be a 3-video playlist, we will actually build a very cool chat app using Ktor, including MongoDB server-side. Client-side, we will make a simple Android app. That's not a surprise here with Jetpack Compose and sticking to the clean architecture guidelines. And that's what we're going to do in the next 3 videos, including this one. So first video will be making the server, which will be this one. Second video will be making the app, which I will show you in a moment. And the third video will be where I show you how you can actually deploy that to your very own server so you can use the chat with your friends. So let's take a quick look here in the app and how that will look like in the end. You can see we just have a very basic text field where we can enter a username. That will just be one single public chat room where everybody can join who has the app. So let's actually take a look. Here we can join with Philipp. Say join chat. Right now there are no messages. We can join with another account like Peter here, for example. Click join chat. There we go. And now we're actually already ready to chat. So we can say, hi YouTube. And when we then click send, you can see we actually sent the message. It arrived in real time here on Peter's account. We can reply here with, hi Philip, what's up? Something like that. I don't know. Send that, and you can see it's basically instantly there. And that is what we will do in the next 3 videos. And I think this is a very exciting topic. A lot of people ask me to make more about Ktor, MongoDB, just having some kind of own backend that you use with your Android app. This will use WebSockets, so you will even get to know a little bit of that. And that will be very exciting. And at this point, I want to thank my sponsor, Hostinger, who will provide the server we will actually deploy this chat application to. They currently have a huge Black Friday offer here on their website. You will find the link down below, hostinger.com. So in case you actually also want to deploy your app and you want to use that with your friends, which totally makes sense, then you can find their different plans here on their website. And once you decide for a plan, you can see they really offer a lot, like up to 100 websites, lots of storage. Once you decide for that, you can simply click select here. Then you will get to this order page. You can pick your billing period that you prefer, enter your details, payment methods. And what you don't want to forget here is to actually click on have a coupon code, because you do have a coupon code. If you're watching this video, you can simply use the code Philipp7. And then you will get additional 7% on top of that even very cheap price, which is just $2 a month for a server you can just deploy your backend to. And that's pretty cool. Once you're then logged in, it will look somehow like this. So this is basically your web interface in which you can manage all your servers. They also have a very great web hosting plan, shared web hosting. If you decide to have a website, then I can only recommend having that as here on Hostinger. You can have a domain. You can see I registered a domain here, which is currently very empty. And I have a VPS server. That is what we're going to use to deploy our chat here to. VPS stands for Virtual Private Server. It's in the end just a virtual machine, a remote Linux machine where we have root access to. So we can install all the stuff we need on that server, like MongoDB, for example, and then simply use that to, chat with our friends together. So that's pretty cool, and I'm looking forward to that. Okay, there are 2 things you actually need to do before starting with this course. On the one hand, you need to create a Ktor project. So in case you've never done that, then you need to go to start.ktor.io. And here you will actually find that project generator. There is a plugin that is available for IntelliJ, which is the IDE that we use to make that Ktor server. So you also need to download that in case you don't have it. However, that plugin is only available for the ultimate version of that, which is paid. And for those who don't have that, you can use that Ktor project generator website here. It's free. You can basically just configure your project here and then simply download the initial project as a zip file. For this project, if you don't want to do this, you will also find the GitHub link in this video's description, where we will find the initial project setup that you can just pull into your IntelliJ IDE. So here on this website, you can see you can choose a project name. I will just choose Ktor Chat. We can open this, adjust project settings block here. You will see you can enter a website, which will in the end just make up your package name. The artifact, yeah, it will pretty much be the same, also some kind of package name. You can choose a Ktor version. I will just use the latest stable one, 1.6.5. The engine is fine, leaving that at nutty, and the configuration file will be a hocon file, so that's just, yeah, it's similar to JSON, in which we will basically just put our server configuration. We can leave this checkbox checked here to add some sample code, because before we actually generate this, we want to click Add Plugins. And let's think about what kind of functionality we actually need in our server to make our app. On the one hand, we need sessions. So we want to store a specific session by a user when they are actually connected to the chat. You will see later how this works. It automatically added this routing block as well, which we need because we want to be able to have some rows at which we respond with content. Then let's see, we have content negotiation. Not sure right now if we need this. I will add it. This is basically for JSON parsing. So if we want to automatically parse some data to and from JSON to send it over the network, I actually don't think we need that. I mean, we need serialization, but we don't need that automatic serialization. So let's actually remove this. We will see later. In the worst case, we just have to add another dependency. We can add call logging. That's just, yeah, for convenience. Then we'll see if a client makes a request. And let's add Kotlin X serialization for serializing some data. As I said, we will do that manually here. And then only WebSockets is missing. So WebSockets, in case you don't know that, that's just for real-time communication. So we just establish a fixed connection between two clients, and yeah, they can basically send data to each other at any time. So that's pretty cool. We're done here. We can click Generate Project. And then you can see it will download that as a zip file. You simply put that in your IntelliJ project folder, extract that, and then you can open it in IntelliJ. So I will see you back in IntelliJ. So there we go. That is our empty Ktor chat project here. Let's quickly walk through this so we can actually understand this and just see how the typical Ktor structure looks like. So it's quite similar to Android, actually, a little bit different, but yeah, you also have that source package with your source code. You have a main package and test package. We're not going to write any test cases here, so let's open the main package. Kotlin, and here you will find a plugins package and an application class. If we take a look in the application class, that's basically the entry point for our server. You can see here is the main function, and it will just call that engine main.main, which will then trigger this module. So you can use Ktor with multiple modules that you define in your code, but we are going to use the single one here, which is totally sufficient. Let's take a look here. You actually have a lot of these configure blocks. So these configure blocks configure so-called plugins. You've seen these when we actually created the project, which were, yeah, these options that we actually checked, like WebSockets, like serialization here. In Ktor, these are called features. So a single feature is just a single thing your server can do, like serializing data, like WebSockets, like routing. That would be a feature. And with these configuration blocks, you can actually just define how you would like this feature to work. The actual configuration you will find in the plugins package. So let's take a look at routing, for example. And you can see it just inserted some sample code how routing would work with Ktor. We can remove that here because we really don't need this. If we take a look in serialization, for example, you see we can just install this content negotiation feature and basically just set up JSON here. So that was set up Kotlin serialization. And you can see when we then would respond with such a map, for example, it would automatically parse that to a JSON string and respond with that at that specific route. However, we also don't need this, so we can also remove it. And if we actually take a look here at the left, then you will also find a resources folder. If we open that up, you will find two files. Only one of that is interesting for us, which is the application config file. If we open that, you can see that's just the file in which your server configuration belongs. This is this hoconf file I talked about. Here you can define your port where the server is running on, your modules, and a lot more. Like if you have some secrets like JWT authentication, then this would be the place where you put this. Or if you have an SSL certificate, then you can configure that here in your config file. And if we take a look at the root level of our project, then this will look similar to Android. We have our build.gradle file, which is the Kotlin version of Gradle here, which are actually like more. If we open that up, you will just find your dependencies that are already included here. I will include some more, which I will explain what these are for, just pasting these. On the one hand, we have kmongo. Kmongo is a Kotlin library that is able to access your local MongoDB that is running on your machine. I will show you in a moment how this works. So just make sure to add these two dependencies. And then also add these three dependencies here, which are for Koin. So we will use Koin here for dependency injection. On the server side, we don't have stuff like Dagger Hilt. So here we will use Koin. And you can see we still need to define these versions, which we can do in this Gradle file up here. We can just duplicate the last line twice here. Have our kmongo version and our Koin version. And we can then define these versions in our Gradle properties file on the left side here. On the one hand, we have our Koin version, which is it is 3.1.2. And we have our kmongo version, which is 4.3.0. If you've done that and made sure that there are no more errors in your Gradle file, you can click this little sync icon here to synchronize your Gradle and just to make sure that the changes are applied. And well, right now we wouldn't be able to use MongoDB because MongoDB is actually a program that needs to run on your computer, on your local machine. Because of course, if you want to save some data in that, you actually need some kind of program to talk to send commands to. And if you don't have MongoDB, so if you have that, you can skip this section. But if you don't have that, which is pretty likely if you never worked with backends before, you actually need to install that. And for that, I have this link open here. You can find this also down in this video's description. It's mongodb.com/try/download/community. So it's a free community edition here. You can do whatever you like with that. So make sure to open this community server. Choose your version, preferably the one that I use here. Choose your platform, your package. For Windows, I will use MSI. And click download. And a few seconds after that, once that is downloaded, you can actually click that installer and install MongoDB. So that's what we're going to do here. Let's click that. And this wizard will open up here where we can then click next. We want to accept this license agreement. Next, you can just click complete install here. We want to leave everything as it is, basically. I won't install that in my machine here because I already have it. So you just want to make sure install it as a service, run service as network service user, clicking next. And you also want to make sure that this checkbox is checked to install MongoDB Compass. That is actually optional, but it really helps with development because that's basically the, not really graphical version of that, but it is a Windows program in which you can just click through your Mongo collections and you just see what's in your collections. So it really helps debugging. It really helps changing a few fields without actually needing to learn Mongo on the command line. So once that is done, I won't click next here. We will go back to IntelliJ and actually now start to work on our project. I will close these windows here and we will actually start on our data layer. So we will start to write the MongoDB stuff. In our root package, I will create a new package called data. And in that data package, we will have a model package. It's a very, very simple database here, because in the end we just save our messages that we send into our chat to be able to load these initially when we join a room. So in our model package, we're just going to have a single model, and that will just be called message. I will select data class here. And let's think about what kind of information we actually need to save with a specific message. So on the one hand, that is of course the text the message actually reflects. So obviously every message has a message. Surprise. We will also need the username of the user who sent the message. And we will need a timestamp, type long, so we actually know when the message was sent. And because we save this message in our database, we also need a unique ID for that, so we can actually uniquely identify each message and also find that easily with our queries. We can simply define this ID with val ID, will be a string, and we default this to object ID, this one from org.bson.types, create a new object ID and say that to string. So that will just generate a random ID that we assign to this message. And because this is an ID, we need to annotate this with @bsonID. We want to import that, and there we go. One more annotation we actually need is the serializable annotation, which just sets this class up to be able to be serialized with JSON. Because later on, when we implement our WebSocket stuff, then we will just take such a message, serialize it, so we have that as a JSON string, and then we send that JSON string over the network in real time to the other app. So now that we have that message entity, we want to actually implement our data source. So we just want to have an interface that defines the functions we actually need to access our database. In our case, those are just two functions. On the one hand, to get all messages, and on the other hand, to actually insert a message into our database. So in data, we create a new Kotlin class of file called message data source. Select interface. And as I said, these will just be suspend functions, of course asynchronous here because of I/O operations, writing to a database and stuff like that and reading from it. This will be get all messages, and it will return a list of messages from our model package. And we're going to have another suspend function, insert message, where we just pass a new message and insert that in our database. Now we need an implementation of this data source, of course, to actually use that in combination with MongoDB, because I'm actually doing this interface here to have that as an abstraction, because then we can actually pass that to wherever we like without actually specifying, hey, this is specifically for MongoDB. Because if at some point we decide to have some other kind of DB, then we don't need to change this interface. We only need to change the underlying implementation, which just allows us to not need to change a lot of stuff in our code. So in our data package, we create a new Kotlin class again. This will be message data source implementation. And it will implement that message data source interface. We can press Ctrl-I and implement all these functions. And this will take a constructor argument here, which is our actual database instance, and that will be of type coroutine database, which is an instance you can see of kmongo coroutines, and it's just a database instance, that uses coroutines to write and read from our database, and to actually now get access to our message collection. So in MongoDB, we just save everything in collections of documents. It's just like in a Firestore, if you know that, or real-time database, just JSON blocks of data in the end, key value pairs. And if we don't have such a collection yet, kmongo will automatically create that for us. It's really easy. We can just define our messages collection here, actually make that private, using db get collection and passing our type message. It's really that easy. That's all we have to do to create that message collection. It will automatically know how a message looks like, and if it does not exist, then it will create that the first time we actually insert a message. And the next step is actually to implement these two functions, which is as easy as actually creating the collection. Here for getting all messages, we can just return messages collection.find. We don't need to pass any arguments for that find function if we want to get all messages, which we want. Then we can say that descending sort, we just want to sort these descending by date. So we just pass our timestamp. And here in KMongo, we can simply do that using the actual entity class. Double colon, specifying the field we want to sort by, which is the timestamp. And then we can say toList. And it's really that easy to get all messages from our database in KMongo. And to insert a message, that's even easier. We can just say messages, insert one. We just want to insert a single message. And that is the one we pass as a parameter. Okay, what is the next step here in our project? The next step is that I actually want to write a so-called room controller, which is the control of our room. It will manage the chat sessions. So we only have a single chat room, and the room controller will just make sure that it keeps all the references to all the members that are currently joined in that room, including their specific WebSocket sessions, which we can then use to send messages to these users. Let's go to our root package, create a new package called room. And in this room package, we will create a Kotlin class called a member. So a member will just be a single user who is currently in our chat room. And this member will need 3 fields here. On the one hand, the username. Then it will need a session ID, also of type string. So a session ID is just a unique identifier for a specific session. So as long as that member is connected. And it will need, what else will it need? It will need a WebSocket, which is a WebSocket session. So the socket is what we then use to actually send something to that member. And in the Android app, we will then receive that message and display it correspondingly in our chat list. And one more very, very small class that I want to define before jumping into the chat controller, or the room controller I call it, is just a custom exception. So in our room package, new Kotlin class, and that will be member already exists exception. So if we actually want to join a room and there is already a member with our username in that room, we just throw this exception and display corresponding error in the app. So we can simply let that inherit from exception. And for the text here, let's put that in another line. Basically just say there is already a member with that username in the room. Something like that. And then we can go to room package, create a new Kotlin class, and that will now be our room controller. Just like this. This will actually need our message data source. Now make sure to pass that interface. Because in this room controller, when we send a message, we of course want to also insert that in our database. The first thing I want to define here in this class is a private val members. So we are actually going to use a so-called concurrent hash map to save our members that are currently connected to our chat. So what is a concurrent hash map? I hope you know what a hash map is. It's basically a data structure that saves key value pairs, and it's very efficient to actually read these key value pairs. And the thing is, server-side, we often have a lot of multi-threading going on. So a lot of requests going in at the same time, a lot of database operations are currently happening. And if we then use data structures and we don't make sure that we actually deal with this concurrency, then we can face a lot of so-called race conditions. I won't go deep into that here, but this concurrent hash map actually knows how to deal with that and make sure that that only one thread at a time is actually writing something to that concurrent hash map. So the keys will be strings, which are the usernames, which are unique, and the values will be our members. And here we can just create an empty version of this hash map. Then let's actually next think about the functions we need in our room controller. On the one hand, we want to have a function on join. So when a new member actually joins our room, this will take the username of that member. It will actually take the session, or actually not the session, instead just the session ID, just everything we need to create such a member. And also the socket, which is a WebSocket session. So in here, let's think about what we do when a member actually joins the room. When they do that, we want to check if there is already a member with that username in our hash map. If so, we will simply throw the exception we just created. So if members contains key username, we want to say throw member already exists exception. And if that's not the case, we say members at the key of username is equal to a new member. And we can say, okay, username is username, session ID is session ID, and the socket is the socket, just like that. So what else do we need? We also, of course, need a function to actually send a message. So when a specific user sends a message, we want to broadcast that to all members in this room. So far so good. Let's write that. Function send message. Here we need to know who actually sent that message, because we will attach the sender username to that message body, so everybody can actually properly display who sent that. And on the other hand, we of course want to know the message we actually want to send. And that's just a string here. In this function, we will then create our message model for our database. So we can say, actually not a val. We first want to take our members list, our members hash map, and say for each value. That's fine. And it gives us an error. Or let's do members.values.for each. Yeah, that works. So here, for every single member in our members hash map, what are we going to do? First, we actually want to create an entity for our database. So message entity is equal to message. The text will be our message. The username will be our sender username. And the timestamp will be system current time millis. And the ID will automatically be created. So far so good. Let's actually use our message data source and insert that message into our database. So message entity. Since that's a suspend function, we need to execute that in a coroutine. Here, I'm going to just make that a suspend function as well, so that error goes away. But we're not done yet in this function. Right now, we just save our message in the database. We also want to parse that message to a JSON string and then send that JSON string to all members in that room. Because we can't just, of course, send a message object via WebSockets. We can only send strings or just bytes in the end. In the end, a string is just a set of bytes. So we will have a parsed message here using Kotlin serialization, which we can then simply say JSON, I think this one, dot encode to string. And I think this is actually the wrong function. We should just be able to pass our message entity. And yeah, you can see we can import the correct one pressing Alt plus Enter. There we go. And then we can say member. So the current member we're referencing here in this loop. We take the socket of that member and we send a frame. So a frame is just something that can contain data. It's basically something we can send via WebSockets. There are different types of frames. We want to send a frame dot text because we just want to send a string here. You can also send byte frames if you want to send some file data or so. I don't know. And here we just say parse message. And that's now it. That's how we basically send a message using WebSockets over the network. Then two more smaller functions are missing for this class. On the one hand, that is just a function to be able to access all messages and to read these from the database. That's a very quick function, just suspend function here, get all messages, returns a list of messages. Oops. And we can just say return message data source, get all messages. And finally, if a member decides to disconnect, if they leave the app or so, we also want to have a disconnect function. So we say suspend function. Actually, I will call it try disconnect, because if the member is not in the room here, there is nobody to disconnect. Then in here, what we will do, we will say members. Actually want to pass the username here, who we want to disconnect. Members using the key username, .socket.close. So we just want to close the socket connection to that specific member. And then if there is a key in our members list called username, we actually want to say members.remove username. So we just remove that member from our hash map. And that's already it for this room controller class. The next step is to actually set up our sessions. Because every time we connect to the server here, we want to set up a session and connect that or to associate that with a specific member who joined. And for that, I'm going to go to our plugins package, create a new Kotlin file called sessions. Just a plain file. And here we'll extend the application class with another configure block and call it configure sessions. And I realized I put a hashtag in there. We'll quickly remove that. So what will we actually put in here? We'll first of all install the sessions feature. I'm actually not sure if we have that somewhere else here. Security, oh, here we already have that. So then let's actually remove the sessions file again, sorry, and configure that here in configure security, removing the routing block. And yeah, that's basically how we do that. We define a data class that contains our session data. I will actually not do that in this function. Instead, I will create my own data class for that. Question is where. I will create a sessions package in our root package. And in that, we will have our chat session. Simply create a data class that will contain the username of that user, and it will contain a session ID. And back in security, we can install the sessions feature. We want to have a cookie. We can remove this stuff. We'll just call it session and replace my session with chat session. And then another thing we want to do here is we want to call intercept application call pipeline.features. And this is now the place where we will actually assign the session. So this will now take a look at each and every request client makes to our server and takes a look, okay, is there session data attached? And if so, it will assign a corresponding session. So we can check if call.sessions.get passing in our chat session type, so it knows which session we're talking about. If that's null, so if there is no session for this particular user, we want to say call.sessions.set, and we say a new chat session. The username will be actually something we can get here as a query parameter. That's how we will attach that. So val username is call in this case. So call just refers to the current call by the client and contains information about that. Just like parameters, for example. Here we will have the username parameter. And let's say if for some reason that's not provided, we just assign the name guest. Then we can say username and session. Actually, we have to generate a session ID here. We can simply do that with generate nonce. So that will just generate a random string here. Okay, we're already pretty far here in our server. What's now missing is the actual route at which we connect with WebSockets, at which we receive these requests from our clients, and then properly use our room controller to actually handle that. And we need our co-in setup. So we have dependency injection and stuff like that, which is very simple. So let's actually start with the more complex part, which is the route. Actually, two routes. On the one hand, we have a route to get all messages. On the other hand, to connect to our chat. So in our root package, we will have another package called routes. And in that, we're going to have a file called chat routes. Select file. And this will also just be functions in Ktor, extending the route class. And the first one will be the chat socket route. This will need an instance of our room controller, which we will make use of here. So first of all, we want to specify that we actually want to be able to receive WebSocket connection here at that specific route. So we say WebSocket, and here we can also define a path at which we want to connect here. So basically just a route, which will be /chat-socket. So that's just the URL we will connect to. Then the first thing we want to do is we want to get the current session by this user. So we can say val session is call.sessions.get. That will be of type chat session. And with that session, we just now get information about that specific user, for example, like the username or just the session ID. If this session is actually null, which shouldn't happen, oops. If session is null, come on, then we actually directly want to close this WebSocket connection here, because then we don't want to connect to the chat if we don't have a session. So we say close, and we can pass a close reason, so the client would know why that's closed, or yeah, I don't know what's the exact use case for that close reason, but we can provide one here. Close reason codes. The dot violated policy, we can attach a message, which would be no session. And we of course want to return out of this WebSocket block. If we however have a session and we arrived at this point in our code, we can say room controller on join and actually join our chat. The username will be session username. Session ID will be session.session ID. And the socket will just be this. So actually just this. So this will be the default WebSocket service session, which we get here in this block. So this will now be called every single time a client connects to this route via WebSockets. So then we actually get the corresponding socket connection we can then attach to the member to use to send something to that specific member. Because this could potentially throw an exception here, our member already exists exception, let's put this in a try and catch block. So if there is a member already exists exception, we just want to handle that. In that case, we would just say call.respond with the conflict, with the status code conflict. So we can pass conflict here. And yeah, we could also attach a message. We probably don't need to. We can just treat this the same way as we just do it here. So if we receive a conflict code client side, then we just say, okay, the member already exists. We also want to be able to catch other exceptions, because when the socket connection is closed, it will actually throw an exception. So in that case, we could simply print that. So either print stack trace. And one more thing actually in this try and catch block is a finally block. So what we actually want to do in each and every case, no matter if this succeeded or failed, after we actually went through this try block or these catch blocks, we just want to make sure that the socket is closed properly so that we properly disconnect from the chat. So we say room controller, try disconnect, passing our session username. Because we're not done yet. After we actually joined the room, we want to say incoming. So you can see that is now a received channel. We can say incoming consume each And here we get the frames. So this piece of code is now called every single time there is a message sent to this WebSocket. So yeah, I know this is a little bit confusing right now. So we basically have this WebSocket connection, this WebSocket server session here, which is the socket connection to a specific member. And if this member would receive a message, so if there is a message directed to this member, this block of code will fire off with the corresponding frame. And that frame, usually in our app, will just be a text frame. So if frame is frame.text, then we say our room controller send message. The sender username is just session.username. And the message we want to send is actually frame.read text. So that's how we decode a frame and actually get the string as text. So just for every single incoming message, for every single message that comes from this particular session, we just broadcast that to the whole room, if that makes any sense. Then one more route, as I said, that we need here is actually to get all messages. That's a very simple route. Get all messages. It will need our room controller. And here we just have a get request. We can simply say get, define the route at which we want to access that, which will just be messages here. And we can say call.respond, import call. We want to respond with HTTP OK. And we want to say room controller, get all messages. And we can even put this in separate lines. That's really everything here already. There isn't much that can go wrong when we access this route. We just return all messages from our database. And yeah, functionality-wise, that is already it. As I said, we still need to set up Ktor here for dependency injection, which is very simple. So I actually just want to create another package in our root package called di for dependency injection. And in there, we will create a class called main module. Actually, not a class, just a plain Kotlin file. If you know Dagger Hill and Android, you will know what modules are. I won't deep dive here into dependency injection. We will just define that main module here. That's how we do that with Ktor. We have this module block. And in here we can define the dependencies that we actually provide. On the one hand, that is our database instance. So we can say single to define a singleton. And we say kmongo. Actually, this one here from reactive streams dot create client dot coroutine. This will create such a coroutine client. And then we can say get database to get this coroutine database I talked about when we provide a name. So we can say message DB. I will actually attach YouTube here because I already have a message DB. So that's how we provide our database instance. Then we need to provide our message data source. So another single message data source. And here we say we return message data source implementation. And now how do we get our coroutine database in here? Well, because Ktor knows how to create that, since we defined that here, we can simply say get. Just like that, and it will automatically insert that. Then, what else do we need? Just the room controller. That's pretty much it afterwards. So we can create that here. And since we also know how to create that message data source, we can again just say get. So far so good. Let's have a plugin here to configure Ktor. Actually, let's not do that. Let's just directly do that here in our application class. At the very start, we say install Ktor. And we can configure that here. All we really want to do is we want to say modules. We just want to define the modules we have here. And we just pass our main module. And that's pretty much it. So if we now want to run this server, you can simply click this play symbol next to main. and click Run Application KT. Let's hope everything goes well. If not, we will fix things, but I think this should actually be it. You can see, for me it will probably crash right now. For you, it does not have to. You can see, because Ktor is already in use, that's the issue if you're actually launching a server on a port that's already running. So where there is already an application on your PC taking that port, which is the case for me. Doesn't need to be the case for you. If it works for you, that's totally fine. Then you don't need to change anything. I do need to change something. So I need to go to application config and actually change this default port to something that's free on my machine. I typically just use, yeah, we can just do 8082 or so, relaunch this, and then this should not crash. And no, it doesn't. So how can we actually now test this? Because we obviously don't have the app yet. Well, there's a cool website where we can actually do that, which is actually this website here. So it's pisocket.com/websocket-tester. So this WebSocket, this website we can actually use to connect to our WebSocket server and send messages, and then we will see how the server responds. So here for the URL, I will pick WS, which is the WebSocket protocol, localhost 8082, which is the port I've chosen, /chat-socket. And let's actually click connect and hope this works. Connection failed. Okay. Let's actually take a look in our server. Why that failed. Okay, it was not found. I know why it failed, because I forgot to set up our routes. When we define the routes in Ktor, the way we did, you can see these are still unused functions. We need to call these in our routing feature. So here in routing.kt, we simply need to say chat, actually not chat socket, or it's actually install routing. Is it like that? I think so. If we say, whoops, install routing, and here we can then say chat socket, passing the room controller, which we can get from Coin, and get all messages. How do we get that room controller from Coin? That's super simple. We just say val room controller by inject. And then Coin will inject that. Passing room controller here. We don't need any parameters. It's that simple. Let's relaunch that and hope that actually now works. And no, it doesn't. Application feature WebSockets is not installed. Okay, that, I think I know why that happens. In our application class. So you see we do have WebSockets configured and installed. However, we try to configure a route that uses WebSockets before we configure the feature. So all we want to do is we want to swap out these two lines that we configure WebSockets before the routing. Let's try again. And it still doesn't work. Conflicting application feature is already installed with the same key as routing. So it seems like somewhere we already have that routing feature. Let's take a look and configure sockets. And there we go. We have two of these routing blocks. That's a disadvantage if you actually have this option of adding sample code enabled. Then Ktor will add all the sample code. We can just remove this routing block in the WebSocket feature. Let's take a look in the others. No, we don't have any other routing blocks. So let's now relaunch this. Now it doesn't crash. Going back to our website here, clicking connect again. This time it says connection established. So that's pretty cool. If we take a look in our server, actually this one, then can we see this here? No, not really. Usually it should actually say that there was a connection if we have call logging. But let's actually just send a message into that and see. So we can now say message, and we say, by the way, we need to reconnect because I didn't attach username. We can do that as a query parameter here. Username is Philipp. And now connect. Sorry. Now we establish a connection. If we now send a message like, hi, what's up? Clicking send. And yeah, that looks pretty good. So we sent hi, what's up? And this is what we received from the server, which is basically the JSON string of the message, which is now sent to all members in that room. And yeah, you can see it automatically generated an ID. We can also find that in our Mongo Compass program, actually. If we do open that up, then this is probably not how it will look like for you. There will be a field with a connection string. You can just leave that empty and click connect, and then this will appear for you. And we can then simply click refresh here. And you can see here's our new MessageDB YouTube. If we click on that, there is a message collection, and there's our message that we actually sent into our chat. And here you can then edit that as you like, you can delete it. This is how you manage your local database now. But yeah, it seems that everything actually works well. I know this is a long video, and I can also tell you the next videos will also be quite long. But this is actually a pretty cool project to get started with Ktor, to get started with WebSockets, and just that server stuff combined with Android. It will be pretty cool to learn something new for you. So in the next few days, you will find the next part where we make the Android app somewhere here, not sure yet, but I will include a card here, and then you can simply click on that and go on with this playlist. And then a few days after that, I will show you how you can actually deploy that to a Hostinger VPS server.